And welcome back to another edition of Mr. Hamilton teaching AP Environmental Science. Today we're going to be talking about one of our energy sources known as coal, and we're going to look at how we change this rock into electricity and the environmental impacts from burning and extracting the coal. Okay, coal is basically a fossil fuel. Fossil fuel meaning that it was created a long time ago as a fossil, and depending on the amount of pressure and heat and time provided in the environment, it changed from one form to another to another. So there's basically three types of coal. When you look down at the diagram below, you'll see this word called peat. Sorry about that. And peat is not really coal, but it's the preliminary form of coal. All right. Then if you add a little more pressure, you get a material called lignite, which is the formation, the first start of the coal. It's usually the softest coal, the one that has the least amount of heat and time. And then you get to the most common type of coal of all, and that is called bituminous. And it could be subbituminous or bituminous. Bituminous coal is, like I said, the most common, but it is also the dirtiest. It has the most amount of pollutants. It has the greatest amount of impurities. Then you get to the last and best of all coal called anthracite. And anthracite is the one that has the greatest amount of pressure, the greatest amount of heat over the longest amount of time, therefore making it the hardest coal and the cleanest burning coal. Our supplies of anthracite are not as great, nowhere close to bituminous. But Pennsylvania has a fair amount of anthracite coal, therefore making Pennsylvania a very good and important coal state. All right. Now, with that knowledge, we can move on. If my wonderful PowerPoint will go. There we go. And we're going to talk about how coal is actually used to make electricity. In a coal-burning power plant, or a coal-fired power plant, the supply of coal is usually through a conveyor belt put into a boiler, which means it's at a place where you burn the coal. When you burn the coal, what you do is you send water into that burning area. Water obviously will turn into steam. Steam you then can compress and fire at a high rate of speed into the turbine. The turbine then spins through a series of blades, which you see here. They will spin, and they're connected to a magnet and a coil of wire. That coil of wire spins inside a magnetic field, and out comes electricity that gets sent to your home. That's the process. Very simple process. Then, once you burn the coal, you also obviously have air pollution or exhaust, smoke, whatever you want to call it, and that goes up the smokestack. All right, and then out into the atmosphere. Now, obviously, there is a point in here which is not shown in which you have some sort of air pollution controls that this particular diagram doesn't put in there. But those pollution controls, most common being a scrubber, which we're going to get into great detail later. But a scrubber basically cleans the exhaust before it goes up and out the stack. And so when you see the exhaust coming up out of here, understand that there is some sort of barrier in here, some sort of device which actually removes some of the impurities. But that's the basic idea. Coal is burned to turn water into steam. Steam then runs a turbine. The turbine then is hooked to a generator, which makes the electricity. Okay? And that's the basic process. Now, we're going to get into some of the details of the process. If I can come out and go into my PowerPoint, see if it'll go. Let's put it this way. It takes a lot of coal to run a power plant. We're not talking about small amounts of coal. So the problems are just multiplied by the amount of coal that we need. When you burn the coal, you do have the exhaust that comes out. And this is kind of a deceiving picture because you'll see that you have one smokestack here giving off the smoke, and then you see nothing above this particular smokestack. That does not mean that smokestack is turned off. What that does mean is this particular smokestack was scrubbed or cleaned of all the visible pollutants. And so what's coming out of there are the invisible pollutants. All right. So just because you don't see smoke coming out of a smokestack doesn't mean that it's clean, or doesn't mean that it's there's nothing happening. And again, smoke coming out. So what is the problem with the smoke? Well, let's take a look, first of all, of where in the United States all these power plants are. These are all the coal-burning power plants in the U.S. And if you look around and you kind of look at the size, the total amount of production each one, the blues are the smallest in production, okay, or the cost, I should say. And the size of the circle, I should say, is the amount of production. But you can kind of look closely, and you'll see there's a concentration of them right in this area, which is going to become very, very important. All right. You have then scattered many along the east coast of the United States, down in here, across the Midwest, straight through here, and much fewer out in the western part of the country, mostly because the population is much lower and you don't have the need for the electricity. But what we're concerned about is this place in the Midwest, because trade winds in the United States move west to east. So any of these pollutants that are coming out of this particular coal burning process and these power plants is going to head east, right towards Pennsylvania. And you're going to see the results of that here. Okay? And I apologize, it just takes me a second to go through. So here is one of the problems. This is an impurity that's in coal, all right, known as sulfur dioxide. All right, sulfur dioxide will eventually, when it go up into the atmosphere, the smokestacks can push it way up in the atmosphere into the higher levels of our troposphere, move with the winds, combine with water in our atmosphere to form sulfuric acid. And that sulfuric acid comes back to the ground in a form known as acid rain, or more technically known as acid deposition. Very important word. This comes right directly from coal being burned and the impurity of sulfur being put into the atmosphere and caught up in the wind, sent eastward. And if you look at it, the numbers on here is the pH of the rainfall. And you know everything less than 7 is an acid. And the lower the number, the more acidic it is. And on the pH scale, every one number lower is 10 times more acidic. And the most acid precipitation is falling right across our area, which is perfectly consistent with all those coal-burning power plants right here moving up in our direction from the Midwest. So we here in Pennsylvania are getting 4.4, 4.7 pH acid rain or acid deposition, and that's all coming from those power plants in Ohio, okay, in Kentucky, and out in the Midwest, pushing all of that sulfur dioxide our way. Again, look out west, and you can see that they have no acid rain. Normal pH of rainwater is actually 5.6. That would be perfectly normal. So they are right around that mark. So it's all an East Coast issue, all because of power plants putting out sulfur dioxide into the atmosphere. And that's not all they put out. Another impurity in the coal-burning power plants is mercury. Mercury is a heavy metal. It's a neurotoxin, can cause severe health issues. And again, if you look at the situation with the coal-burning power plants up here in the Ohio Valley in the Midwest, all right, all of that air pollution heading eastward right into Pennsylvania, and you can see where the mercury deposition is at its highest. That is coming out of the sky through rainfall, going through or mixing with that pollution from the coal-burning power plants and hitting us. So we here in Pennsylvania are the lucky ones to get so much acid precipitation and mercury deposition. Just a wonderful, wonderful opportunity. Not only that, but there's also another problem which is going to be demonstrated here with the Kingston coal plant disaster of 2008. And what you see here is a picture of the Kingston coal-burning power plant. But if you look in the background, you see what looks like ponds. And I apologize again. We'll try that one more time. Okay, I'm not going to bother editing, so you have to put up with my mistakes. But back here, you could see the ponds. Those aren't ponds. One of the things you have to realize is when you burn coal, which you can see the coal supply down here, going into the power plant, when you burn it, not all of it burns. You end up with an ash. That ash is put in holding ponds. And that's what you see in the background here. The only problem is it rains a lot. And when it rains, those holding ponds fill up with water, and you get the ash from burning coal mixed with water just sitting there. Well, unfortunately, for this particular coal burning power plant and the people around there, all right. Oh, by the way, here's just another set of pictures. Again, you'll see, I apologize, right here, you see the ash being transferred. These are, each one of these over here in this picture are ponds of ash mixed with rainwater as it rains. Okay, and then here you can see the ash pretty much being spread out. All right, all held in kind of a boundary here, a little hill that acts as a dam to hold this all in. And that's the purpose there. So, again, in Tennessee, here is what happened. That little hill that's supposed to hold it in broke in a heavy rainstorm. And you can see this part right here is the ash that still remains, and you can see how it was cut away. All of that water and ash mixture just spilled out into the environment and into a stream, which carried it downstream to where people lived. And luckily, there weren't a whole lot of people in the area, but the people who were in the area ended up being completely covered. You can see the first floor of this house completely covered in coal ash water mixture. So the ash that's generated after burning the coal, we have a hard time dealing with that, and it becomes an environmental issue with coal as a fuel source. So then they came up with this idea of clean coal, coal that doesn't make air pollution. All right? And clean coal, from an environmental perspective, is very difficult to try to understand. The coal companies will promote clean coal. There's ideas out there for clean coal, but it's a very difficult process to realize. So what exactly is clean coal technology? Well, as you already know, when you burn coal, it releases one, carbon dioxide, which is a big issue with climate change. In fact, coal burning power plants is our #1 producer of carbon dioxide that contributes to climate change. So that's one big thing. And then other emissions, which I told you about in the flue gas, which is the gas that's coming out of that smokestack. And that is the sulfur dioxide and the mercury. Okay? Now, some of the clean coal technologies that are out there prepare the coal to be burned so that it doesn't produce as much of these byproducts. And we call that process coal washing. All right, coal washing is when you actually take your coal before it goes into the power plant, crush it, and then mix it with a solution that pulls out, like a lime solution, that pulls out the sulfur dioxide and some of the other impurities. Okay, and then it gets sent in to be burned. And we give that the name of coal washing. Or another type of clean coal technology is coal gasification, where you pulverize the coal, heat it up, turn it into a gas, and then burn the gas, which is much cleaner burning. Now, I'm not going to spend a lot of time on these two because these are two ideas that promote clean coal, but they are very expensive and not widely used at all because it just makes coal almost pretty much lose competition with every other form of energy if you do that. So these are two ideas which I think is more of a good idea in that it cleans the coal, but not a very practical idea. So we don't see it that much. So that's coal washing and coal gasification. Okay, keep those two in mind. And then to get rid of the carbon dioxide, the big push right now is for this process called carbon sequestering or sequestration. Again, a very, very expensive process, and one which is not used that much at all. And here's the idea. When you get a coal-burning power plant, you capture the carbon dioxide from that coal-burning power plant, which you can see in this diagram right here, and then you take that and you inject it into the earth. So what you're doing is taking carbon dioxide and injecting it down into the earth, okay, where the goal is that it will not come back up to the surface, cannot contribute to climate change, and it'll be stored basically underground, geologically, using geologic time for longer and longer than we ever have to worry about it. That's the theory behind it. Okay, now where can you actually place the carbon? There's several places that they like to think about. The carbon sequestering can go down into deep salt formations, okay? Areas that they, in this case, where they took oil or gas out of the ground, so there's some space in between the fractures of the rocks where you can put this gas. Or a very popular one is to take it out into the ocean and inject it deep into the ocean, where our hope is that it will never get back up to the surface again. So this doesn't solve the problem of coal creating carbon dioxide and contributing to global warming. It's a way of mitigating the problem, making it less severe by hiding it somewhere on the earth. Okay, again, a process that they use to keep coal and reduce the environmental impacts of coal.